We have here a beam composed by two segments, this one and then this one, connected by this hinge here. We have three supports, a hinge here, a roller here, a roller here, and then we have a concentrated vertical load here, a concentrated horizontal load applied at B, and a uniformly distributed load of 4 kilonewtons per meter. And the objective is to compute the internal forces diagrams. So we're going to start by computing the reactions. So we have one reaction here, another reaction here, as this is an hinge, and then in this and this support we have only vertical reactions. So let's see, we can start by do sum of horizontal forces and using the custom referential. We have minus AX, this guy here, and you have this one here, 10 kilonewtons. So as a result, AX is equal to 10 kilonewtons. If we look at moments to the left of the hinge, the only forces we have producing moment are this one and this one. So you have AY and 10. AY causes a negative moment and the arm is 4. 10 causes a positive moment and the arm is 2. This equal to 0 results in AY equal to 5 kilonewtons. If we do sum of moments around the hinge to the right, we have the distributed load and CY. CY causes a positive moment of 5 times 5. The distributed load is equivalent to 4 times 5 meters, and the distance is half of 5. So this results in CY equal to 10 kilonewtons. If we now do sum of vertical forces, we get AY plus BY plus CY minus this concentrated force 10 minus the distributed force, 4 times 5 equal to 0. This comes BY equal to 15 kilonewtons. So putting everything together, we have our beam here, you have a concentrated force here, another concentrated force here, a distributed force here, and then we have the reactions. 10 to the left here, this is 10, this is 10, this is 5, CY was 10, and BY was 15. And we have the usual 4 diagrams. Axial force, shear, moment. So starting with axial force, if we look at all the forces to the left of this, let's repeat here our convention for positive internal forces. If we look to the left of this section, the only axial force we have is 10, and the same is true for all these sections up to here. So 10 is tension, so you have a force of 10 which is constant up to the support. If you look to the left side, this force of 10 cancels with this force of 10, making the axial force 0 and remaining 0 onwards. Looking at shear, starting here, we first have a force of 5 upwards. Then up to this force of 10 nothing happens. So then we have a force of 10 downwards. So it was 5, it goes down 10, it goes to 5. Then nothing happens until the support. The support we have a force of 15 up. It was 5, it changes by 15, so it goes to 10. From this point onward, we have a distributed force. If P is constant, since dV dP dx is equal to P, it means that V is linear, and it changes the area of this diagram. This diagram is 4 kilonewtons times this distance, which is 5, 4 times 5, 20, it's 20, it's 10, it goes to minus 10. Something like this. And then we have a final reaction of 10 that brings the diagram back to 0, meaning it closes. Now, if you look at the bending moment, we have 4 regions. At this part, and remembering the equation, V is constant, meaning M is linear, V is negative, meaning M increases. So for me, over is linear and increases. The area of this diagram, 5 times 2, 10. Between this point and this point, so from here until the support, it is also linear, but is now positive, meaning it decreases the area of this diagram. The area of this part of the diagram is 5 times 2, so it's 10, and changes 10, resulting in a moment 0 at the hinge. Now in this part, V is linear, meaning M is parabolic. V is negative, meaning M increases, so it's going to increase till this point, which is at the middle, where V is 0, meaning that M does not increase or decrease. So it goes like this. And from this point onward, it starts with a tangent of 0, so it starts horizontal, but then it becomes positive, meaning that the moment starts to decrease. This area here is 10, times 2.5 over 2, 12.5, and then between this point and this point increases the area of this triangle, which is equal to the area of the other triangle, so 12.5 ends up in 0, and the diagram is finished.